Our project is on the 345 to 120 kV substation. This is going to be sponsored by Burns & McDonnell, and our group members are going to be Konner Rugg, Brady McBride, Jonathan Newman, and Moriah Horne. This project seeks to emulate a client This project seeks to emulate a client-consultant relationship where Burns & McDonnell acts as the client and the senior design team takes on the role of the consultant. The general overview of the project has Burns & McDonnell seeking engineering design services for their new Razorback substation. The project is divided into two sections: protection and control design, and network and automation design. The project has been framed as a series of deliverables to be provided. For the first section of deliverables that goes over the protection and control design, one of them is the panel assembly. Now, the panel assembly is a schematic that will show the location and dimensions of the panels inside of the control house. The next is the one-line diagram. The one-line diagram is a high-level view of connections between the buses and relays. This one-line diagram can be seen in the center of this poster at the top diagram. The third deliverable for the protection and control design is the line and breaker, relaying, and wiring. These schematics will show a detailed view of the connections between relays. This is how we show you how the client and how the various functions of the relays are executed.
The next three deliverables are part of the networks and automation design package. The first being an NIA, a network interconnect diagram. This schematic will show a high-level view of the connections between the communications equipment and show how they interchange data. The next will be a communication wiring diagram as shown in the bottom diagram. This schematic shows a detailed view of how our communication equipment is actually powered inside our control cabinet. And the final diagram will be the fiber optic connections. And this schematic will show how fiber optic cables allow different substations to communicate between each other.
The equipment that we are using in this project include the SF6 circuit breakers. We're going to be using 3 of these. And these relays provide protection against fault currents. The relays are set up to trip the appropriate breakers when a high current is detected. The relays that we'll be using include the SEL 311L, the SEL 411L, and the SEL 421 line relays. These will measure the voltage and currents coming to and from the lines and perform the required functions if there is a fault current. We're going to be using a Nokia SAR-8 to communicate with surrounding substations, and we'll be using a Cisco 4331. This encodes the information that is sent to the SAR-8. We'll also be using the Cisco connected grid switch, which serves as an input for multiple fiber connections and aggregates them into one signal.
In conclusion, the goal of this project was to design a substation with a ring bus configuration. Relay equipment is used to detect the voltages and currents within the substation and connected to a SCADA network. The network used to monitor data and control equipment. The data is communicated with nearby substations in order to protect the equipment from ground faults.